Dependency management in a complex world. Um, Before I get into that, I'd like to quickly introduce myself. Um, Roberto Perez, originally from Mexico. I've been at Netflix for 4 years working in what we call the JVM ecosystem team. Basically, what we do is all the experience around building a Java project. So think about the library and application with any language in the JVM, Kotlin, Scala, Java itself, Groovy. So we own the whole experience. We are heavily invested in Gradle. I tried not to be biased in the presentation, take away like those implementation details, because I think these are not solutions, but ideas that apply to mostly any project, and we all suffer from the same things. Yeah, email, Twitter handle. Always happy to chat about this or any other things engineering-wise. Fun. And the reason I'm here is because we have spent at Netflix probably 8 years already on machinery, tooling, around how to make builds better when it comes to dependency management. So to get into that, let's talk about real quick about the life of a developer. So yesterday was Tuesday, right? So Tuesday afternoon, you might have a simple class. It compiles, your build is green. You probably have some continuous integration, continuous deployment platform, or you have ways to deploy that code. Everything is green. You are happy as a puppy here. And then you decide to spend some time with your family, as you should. And the day after, everything is broken. And you ask yourself, like, OK, the only thing I did is check out the latest from my main branch. And you don't know what's happening. As a developer, sometimes you don't carry the cognitive load of those dependencies. Who introduces that or why? So then probably your team will look like this, trying to figure out what's going on. And at some point, someone will ask, are we in dependency hell? And the answer is yes, most likely yes. So if you're not familiar with the term, basically dependency hell means that you have some piece of software that has some binary or dependencies and expect it to work with those versions, but for some reason, it doesn't work anymore. And obviously, it's hard to figure out. So in the case of this example, like it's a compilation issue. It's OK. Instance, like you will probably catch it when you check out the code, try to compile, run a test. But what if you have some sort of runtime thing that happens in production and you don't know what's happening? Because of that, well, and that's one project, right? What if your project has many dependencies? Like today, you go and create a Spring Boot app, any other framework app, and you can joke about it, but you might be downloaded a huge chunk of the internet. Like you create a Spring Boot app that uses Kafka or whatever, you get like 20, 25 modules to start, then all the things that you add for other business logic that you might have, internal libraries. So it's a combination of internal and open source. And as a developer, it's really hard to make sense of this. Like, you know what you're asking for, and sometimes you use things that just happen to be available for you. And then the bigger picture, the case of Netflix, at some point, the company decided to invest in microservices. And we all here heard about microservices, how fascinating they are. The reality is that at this point in my life, I consider this a distributed monolith, in the sense that, yeah, we created microservices, multiple repos, 3,000 something by now in the Java space. But the reality is that people create services and they ship clients. So if you want to talk to my service, like, I don't know, my movie list service, instead of having a contract with an API, whatever, oh, I shipped you a jar. You just use this jar, there is this nice Java API, and you can work with it. So now imagine you want to interconnect all those 3,000 services, and the reality is that the closer you are to the edge, so this might be an application, this is an application at Netflix that serves like front door traffic. So the closer you are to the edge, the most things you need to aggregate. And it's more difficult because now you need to talk to services from multiple teams, and you don't know what they do. You just happen to need to use that code. So going back to this, now we have a problem, binary integration. Every single day, there might be new versions of something, open source, internally. At this point, we have thousands of builds per day, thousands of artifacts getting generated. It could be that there is a substantial change or not. But how do you know as a developer, as an application developer, you really don't care. I personally like the huge emphasis that this conference has had in things like security vulnerabilities, and so on. But still, it's not enough. Like, we need automation to get there. Like, yeah, you can go and poke around to a repository, look at security vulnerabilities, and you might know, okay, I'm using this dependency, but what if you don't know? Like, how do you act to that? So yeah, I'm confused too. What the hell is happening here? What can I do? And our solution or our approach was, okay, you know what? There are so many changes every single day. At that point, we're like 100 projects producing clients. It's manageable. We're just going to run with latest release for everything. It's going to be fun. What happened was someone will introduce a breaking change. The next day, you will get the compilation issue. So we said, okay, we can do dependency locking. Great idea. Every single time you build and you get new dependencies, we create a text file or a JSON file with the version of each dependency that you got and which class path was getting assigned to that. Cool. Do you want every single engineer to run this command every single day? Probably not. They are not going to do it. They will just continue going and going. Their project works. And the problem with this is, either if you do dynamic with dependency logs, or if you do versions here, like real final versions, it's tech debt. When you think about it, let's say you consume some open source library, Jupyter 5. 1 year from now, you need to go to Jupyter, you need Jupyter 6. You know, that upgrade is going to suck, honestly. Like, most likely, you will need to catch up with a year of changes. So really, 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 you need to get to the point where you are constantly upgrading, constantly getting the latest. But as a developer, if I don't have the tooling, why would I? It's really difficult. I already get in task with, I need to do all these things that are for business purposes. I don't really have time to spare on keeping my bill up to date. So we recognize that. And of course, it comes with some cost. So what I would like to talk next is what are the common problems that we have seen in dependency management, not only from the technology perspective when you are compiling code, but also the organizational or cultural thing. So as I showed at the beginning, these are the quite common problems when it comes to my project is broken, I cannot compile. And most of the times it's compatibility issues. It could be a breaking change on the API. Yeah, you don't know. The reality in Java is that we don't have a versioning scheme that people use across the board. Some people do Semver, some people do their own thing. And even then, sometimes they don't even care. Like, it's difficult. Now, the classic thing, multiple logging libraries in your class path. We had outages years ago because we were writing logs to a different place in disk, and it took down multiple important APIs. But you only get these warnings, and that's it. Your application keeps running. As a developer, my application is green, everything is fine, I'm taking traffic, and then I get paged a few minutes later, everything is down. Anyone here uses Scala by chance? You are lucky. Scala, I have strong feelings, but every single time there is a minor version, there are breaking changes. So if you compile something for Scala 2.11, it doesn't work on 2.12 and vice versa. So there is no backwards compatibility. There is no compatibility at all, even in patch versions. So there might be something in Scala 2.12.5 that doesn't work in 2.12.6, which defeats the whole purpose of Semver in this case. So now you need to deal with these things. Misaligned dependencies. You use Jackson data bind, and then you happen to have a higher or a lower version for the other component that Jackson data bind depends on, the core. What's the guarantee that it's going to work together? There is none. And obviously, people are working on creating libraries every day. They do their best in terms of like, how do I deliver change? I'm probably will introduce a breaking change, and my consumers are just going to go and adapt. It's fine. But that's churn on engineers, and that's really like, how to say, it's unfair to say, you know what, I have 100 consumers of this, let's just make it migrate. It shouldn't be like that. And at the very end, Java version. With the new Java release cadence, it's more easy to fall into the trap of compiling things for a higher Java version that is not compatible anymore with the previous one. So if you are writing libraries, well, now you need to understand who is using this thing, so I don't deliver bytecode that it's only targeting Java 17, for example. If all my consumers are on Java 8, well, I'm stuck there. I need to help them move. Common problems on the build space or the dependency graph hygiene are people do not declare the dependencies they need. What I mean by that is sometimes you get into your IDE, you start coding, you get access to classes from Guava, whatever, and you didn't even ask for that in your build tool. So it happens that came transitively from another module. And it works, it's great, but the next day, this might be brought by Spring Boot. So there's a new version of Spring Boot that decided to remove Guava because it's an implementation detail or whatever they're doing. Now your project is broken, and you didn't even know why, and sometimes you don't even know where that class came from. Like, I've been in scenarios where people use string utils coming from Apache Commons, and just because of that, to parse a string or whatever, now you're bringing that module transitively, you depend on it, and it's usually an implementation detail, and when something changes, well, you are broken again. I don't know if you can sense this constant pain as a developer, as a consumer every single day. And then the other thing is adding dependencies that you don't even need. Like, oh, let's just add something. I'm gonna write some code. Weeks later, I refactor, I don't need that dependency, but I only remove the code. I'm still depending on that thing for compilation. I'm still publishing my POM with that, and my consumers are still having that and thinking that they need it in order to work. So just keep trimming the dependency graph, but how can you? You need tools. When you're a library publisher, either OSS or in your company, most likely it's difficult to know who is using your library. I create this library, I probably provide it to your team, and you start sharing with everyone, hey, look at this cool library solving this problem, you should start using it. And one day, it's gonna become so popular that it's on every single project, and you make breaking changes. Now you broke the whole of Netflix in this case. But how can I know who I'm gonna break if I don't know who's using my library? If I wanna do a release, what's gonna happen? Will I break? Is there really someone exercising this particular piece of code that I'm changing? You can argue that you might need some good life cycle in terms of like, okay, you should probably not create breaking changes, you should probably rename the module, whatever. But it is not like that. Not everyone treats APIs the same way. There are different approaches. People like to do breaking changes. We have Semver, everyone is happy, right? Which means Semver is not enough. It is nice that you can really express that thing, but the reality is that people that consume them, sometimes they just get it transitively and they cannot do anything about it. Like, they depend on something that happens to switch the implementation detail, and now they don't know how to move forward, so now they are stuck in all versions of dependencies. So really, the Semver part, it might work. It doesn't work very well in the Java space, in my opinion, but try it. The reality is that there is no way to tell, are you using Semver or not? Can I enforce these things? And if you do, you need to write more tooling, right? And constant change. As I said, we have this dynamic environment where everyone can write services and clients every single day. So now, at some point, if I'm a service owner and I decide to create a new API, how do I move someone from dependency A to dependency B? Can I do it with dependency management, machinery? Do I need to go and open pull request to them? Do we need to ship code changes every time they get a new dependency? Can we do this for the users? Like, as a platform engineer, you probably cannot spare or ask them to go and say, hey, you know what? We have this new library, this new way of accessing databases. You should go and rewrite all your code and then start tracking hundreds and hundreds of projects. It doesn't scale. And of course, security vulnerabilities. It's been a hot topic these last couple days. You will get the insight. You might know which dependencies you are using, if they have vulnerabilities or not, but how can you get the users to move away from that? Can you automate that? Can you reject a particular module from the graph? Like, I don't want to see log4j at all in all of Netflix. How can you achieve that in an automated fashion? And also, like, letting people know that they are in danger. Like, people are focused in their own like business space. If you're working in finance, let's say, you are focusing on getting the finance world rolling, and you're probably not paying attention into security vulnerabilities until they make the news outlets like Log4j. But there are many, like there are hundreds a day. It's hard to prioritize them. So It's definitely difficult. And ownership. It's quite common that someone writes something, it's make it to the ecosystem, this person leaves the company for some reason, and now nobody knows why this thing was written in the first place and who owns it anymore. So that's how you get into legacy, abandoned libraries, applications that nobody wants to touch. But when you need to move the needle to go to new Java, to new whatever, someone has to jump and take that as a task. So it's really hard to get that. So really, companies should be focusing also in reflecting who owns what. If I write a library and application, there has to be some sort of catalog to understand, hey, this library doesn't belong to a particular engineer, it belongs to a particular team organization. So if somebody leaves, well, we're gonna make that team organization accountable for that particular module. So after all this pain, I guess the question is, are there any solutions? Sure there are. There are things that we have done internally and things that are available for you in the open source or enterprise world. I'm gonna go and talk a little bit about them. So I promise to stay kind of unbiased around build tools, so I'll keep it like that, but we use Gradle heavily. So what we did, we created something called Nebula, which is basically a set of plugins for Gradle. And we created this nice tool called Resolution Rules plugin. And the way it works is, as a library owner, you can go and say, you know what, I want to substitute every single log4j version that it's lower than 2.17.1 and replace it with 2.17.2. So as you can imagine, what we do with this is we process that, we deliver that to every single bill at Netflix right away, and then we just let Gradle to take the decision to use that version. Because we're enforcing the dependency management machinery from Gradle, they have the resolution rules. So you can do this like programmatically. Why we did the plugin with JSON files? Because we wanted to be portable in case we wanted to go to another build tool. But the reality is that today, if you use Gradle or Maven, you could probably write plugins that influence the dependency graph and take those decisions for your users. This way, the next time there is a log4j, you can create this kind of rule or programmatically create something that influences the dependency machinery and get the latest and greatest version. Of course, this is just the build part. You need to get that code away. That's the important part. Build hygiene, and I promise this is the last Gradle slide. We have open source plugins to keep linting your build files, removing dependencies, removing bad patterns. And also there are open source plugins from other folks that allows you to understand more about if they analyze the bytecode and see, okay, I see that you're using these particular dependencies, but they are not part of your compiled ones. You should be adding that. Or I see that you declare these dependencies, but you're not using them at all. So this is part of the build hygiene that you should be doing constantly, and you have tools for this. Really, you don't want to do that analysis yourself. It's kind of boring, honestly. And the big question is, who uses my library? So we built something internally called Astrid. And the way Astrid works is, every time we push a jar, it grabs the jar, reads the metadata, and indexes all the information about the dependency graph. So this happens for every single jar, every single module, every single library. And what happens is, when you start indexing this, then you have the whole graph of dependencies at Netflix. So as a user, as an engineer at Netflix, you can go and say, you know what, I want to know where we are on Guava. So then you can see all the versions of Guava and probably click on one of them and get this detail on, oh, look at that. People are using very old versions of Guava, hundreds of server groups deployed in production. This is a bad thing. What can I do about it? So we also provide them this kind of information where they can go and see the drift or the difference between versions in a given module. So they can see if they release a new library, they start seeing like the adoption rate. We are trying to help them to drive change. But what about security vulnerabilities? It's been the hot topic, right? Well, we leverage external systems. We leverage the CVE, database, we have something called something internal called Vulkan. But Vulkan is just basically an aggregation layer from different places, like Snyk or any other vendor that is in this space at this point. So we just go and take that information, and what we do is we create a resolution rule that I showed before. So think about the log4j. We will go and say, you know what? I'm going to create a resolution rule that moves you to the latest log4j. And at the same time, I'm going to create what we call a critical campaigning asterisk, which is fail all the builds that are using an old version. So right away, we don't allow you to even try to redeploy something if you want to rebake. And for someone that is operating these campaigns, it's quite easy. They can just provide group ID, module, the versions they want to, in this case, ban or prohibit on Netflix. And then they get this kind of nice feedback in the sense like, hey, if you do this, you're going to impact all these artifacts, server groups, users, whatever. So you should be conscious that you're going to break all these builds. You better know what you're doing. So this is nice, but constant change. So imagine doing this manually every single day. We have something called Rocket, and Rocket is just some sort of abstraction on top of Jenkins. We use Jenkins heavily. And what we do is, when you create a repo that uses Java, we register that in a database. We know that you're using our tooling. So every single night, we go and clone your repo on a container, runs commands to update the dependency logs, and then open a pull request to your project. So this is kind of the activity that happens overnight. And the next day or overnight, you will get this PR that tells you, hey, we noticed that there are new dependencies. These are the modules that are moving from version something to version another. And you can click and see the changes. And then we also have something called Manage Delivery. I don't know if somebody uses Spinnaker here. Spinnaker is the continuous deployment tool that Netflix created years ago, but at this point it's donated, and there are many people from Google and other companies working on it too. So they created this thing called Manage Delivery, which is declarative deployments. You can have a YAML file because we all love YAML. Everything is YAML these days. And you can go and say, you know what, every single time there is a commit in my main branch, I'm just going to deploy this to a lower environment. And I can decide to do a manual judgment or not to go to production. You are the one, as an engineer, the responsible person for saying when my thing should be on production. So you decide if you want to trust in your pipeline or if you want to do your manual check. So that's up to you. But when you think about it, this is a powerful mechanism because you get a pull request, it gets auto-merged with new dependencies, let's say log4j, and then at that moment, we generate a Debian or a Docker image, and Manage Delivery takes that and deploys it. So magical, right? It's really hard to get there, but it took years to get there. So when it comes to like the log4j edition of this, this is what we call the paypad. So if at Netflix we call the paypad the tools that we suggest you to use, but you are open to do whatever you want, as long as you know that you are taking that decision and you will be responsible for rolling with it. So when you create an application, we can automate all these things for you. You're going to get your dependency updates every night. When you push a commit, you will get the Docker image and Debian, and everything is going to be fine. Probably you auto-promote because you trust that your tests are more than enough to verify that your software is working as expected. Or you might put a canary. They support that. So when it comes to the log4j edition, having all this machinery paid off really well. People didn't see the value until then. That's the reality. So we had engineers that were happy because they didn't get paid. We auto-merged things for them. We auto-deployed for them. It took minutes or hours, depending on how heavy the testing side is for them. But then the engineers that didn't want to be on the paypad, they spent hours or days from their holidays getting pursued by security to get to log4j 2.17. So finding the ability to create this kind of tooling has really paid off. And I also acknowledge that it's kind of difficult for every single company to do that, but I believe that many companies already do these portions or have vendors doing these things in some capacity. So the log4j, because log4j, you can see that with this tooling, we were able to leverage and get to 2.17 quite quick. The fleet continued increasing. until the point that we got like 100% around January 5th or January 5, January 6, something like that. So that's why I found terrifying that the Maven Central still has downloads, because that is not even like the tip of the surface, right? In companies, they probably cache Maven Central, so it's probably 10 times that. And who owns my library? Well, we written something kind of silly in the sense that we are just going to assign teams based on your commit history, and then because we have all the internal organizational stuff, we are just going to also correlate with your team and manager or director, whatever. So that's how we do the ownership. The sad part is that most of the things that I talk right now are not open source. So you may be like, hey, Roberto, why are you here? Like, what can I use from this? Of course, there are bits like Nebula. But there are options out there. I think this space is growing a lot. When you think about updating dependencies, many people know about Dependabot. There is another thing called Steward from Scala. There is Renovate. If you look at constant change, I don't know if you have seen SourceGraph, or SourceGraph started like a company for better code searching, but now they have something called batch changes, which allows you to basically create a specification that runs a container for every single repo that you want and run some code transformation. So you can really do refactoring at the scale without even implementing it yourself. Of course, you pay for it, but not every company wants to spend engineering and money on building their own tool when there are already things that will fit their needs. Ownership, Spotify open source Backstage 2 years ago. And Spotify, the Backstage is basically a software catalog. You can keep track of every single piece of software that is part of your company. And then they have a plugin system that you can even hook things like build information. You can hook things like testing coverage, start grading projects. Like if you were at the Sonatypes talks, that you will get a score for like the security vulnerabilities. Backstage supports like an overall score, not only from security perspective, but also like, do you have things like READMEs? Do you have proper test coverage? Do you have deployments? Things like that. The security space is really big at this point. There is Sonatype, there is MEN, there is Snyk, there is JFrog. I think in security at this point it's more difficult to decide which one to take rather than not having options. All of them have pros and cons. But if you're already in some ways leveraging any of these repositories in your company, most likely you will take that route. Like if you're using JFrog, probably you will take a look at X-Ray. Or if you're using Sonatype, you probably will look at the Sonatype offering, which is similar to the Maven Central one, but for internal things. And refactoring, these are the tools that I could remember. There is Open Rewrite, allows you to refactor Java code using ASTs. There is Combi, which is basically a structured code changes, and Scala Fix. If you are in Scala, well, it allows you to do like, it takes semantic information, and then you can rewrite code accordingly. So I've been talking a lot about the pains that we suffer, how we solve them, what are the options out there, and what's next for us. As I said, there is no confidence to deliver change in some cases, so we want to get into the point where we can do publisher feedback, and by that we mean, okay, if you make a change to a jar or to a module, how do I know who I'm breaking? So really get to the point where people understand what's the impact of the change. And do more distributed refactoring. This is how SourceGraph looks like. You create a campaign that it's a YAML file, you define a Docker image, and in that Docker image you might run some arbitrary commands that you might want. Simple text replacement with seed, it's enough sometimes. And then you just go and open all the pull requests with a few clicks, and you start seeing the trends around for example, the log4j incident response, or how many of them are waiting. So as an engineer, when you are owning libraries, or if you are a platform team, this is really powerful to drive change. And again, refactoring, what if we can just, every time you build a jar, we also provide some sort of refactoring piece. So when you're a consumer, you just get the change, you get the new version, but also you get the code changes that you need. That's like utopia for us, honestly. I guess just for recap, last thought, dependency management is hard. Dependency hell is there. You're not gonna get away from it. We are just here trying to reduce the pain. Build often, release often, and also upgrade often. Producers and consumers have an important role in everything. Both need to be accountable and both need to be responsible for how they deliver change and how they take change. Moving projects from A to B is hard, but there are options out there. I think this space, similarly to the security one, are getting more traction. I wouldn't be surprised if even GitHub comes with their own thing because they already have all these things, right? And yeah, any questions? Oh, feedback, or you can say this is relevant, it's fine.
Can you tell us about the resolution plugin?
Yeah, like what? Sorry.
The resolution plugin.
Oh yeah. Yeah, I try not to make a lot of emphasis. Yeah, so basically we have a repo that has all these rules. We can do things like substitute, we can deny, we can exclude, we can align dependencies. And so you can imagine that we have this repo with many rules. I could probably share, like, we have the open source one. Just one sec. So you have that, and what we do is we ship that as a jar. It's just like another module, and we inject that on every build every single time. There we go. Okay, so there are two pieces. One is applying the plugin, and one is creating rules. And the rules are basically, as I said, JSON files in here. So we have many of them that are kind of reusable. Some people contributed back to it at some point. But you can see things like might be familiar, replace log4j, things like that, or reload 48, blah, blah, blah. So we have all these rules, and what we do is we ship them as a jar, and then on the other side, there is the plugin, which is available in the plugin portal. And when you apply this plugin, you can add a dependency to those rules that you're publishing internally. So you can do this you publish this jar to Artifactory or Sonatype, whatever, and then you just consume this in the, it can be a plugin that injects that dependency, or you can just do it explicit. It depends on how you address your builds. And then from there, the plugin is just gonna download all those JSON files, process them on parallel, and start working with the Gradle API. So under the hood, it basically works with this. So you can do all those things yourself, as I said, like programmatically. But at some point, you cannot ask people like, hey, go into this repo and modify the code. It's going to be more like difficult for them. They just want to get a change out there. They probably are not like well-versed in the whole build ecosystem. So that's why we created JSON files. So once you get that jar, we apply all the rules. And programmatically, we talk to this API from Gradle, and we just keep adding and adding things. Yeah. Any other questions? Raffle time?
What's an approach you would recommend for, you mentioned like limiting tech debt and inspiring or I guess like holding legacy code accountable?
Yeah, good question. I think what we have learned, or I have learned so far, is that engineers really don't want to do changes. So if we could get to the point where we make the change for them, it would be great. But you also need to put some carrots when you need to get them engaged, right? Like, if I'm going to ask you to do something, there has to be some advantage of doing it. I cannot just tell you to go and rewrite your build file because it's fun. You need to tell them, hey, if you do this, from now on, we are going to do all these things for you for free. So you will need to provide tools that they will get out of it every single time you ask them to do something. It's like a reward program in some ways. But so far, it's been the model that we follow when it comes, like, if we don't find any benefit that you can see as a consumer, as a user, then probably we don't even start to get them into the next thing because there is no value. Like, if I ask you to rewrite your application in a new framework, well, what's the reason, right? most of the times we find good reasons, like for example, Spring Boot. We went from something called Governator to Spring Boot, and at the beginning it was, oh yeah, so you can get to Java 11. Yeah, but why? So then we had to sit down with them and say, hey, you know what, because this ecosystem is moving so fast, at some point your application is not gonna work, and it's gonna be difficult for you, for me, for everyone. And that's when they start like kind of realizing, like, okay, it makes sense. But it's difficult to shift that mindset from people on, my build just works, or my application just works, why would I change? So what we try to do is just driving things for them rather than trying to get them engaged. So I think the goal, the more migrations we can do without them even interacting, the better, but it's really hard to get there. Like,
but there's also like the trade-off from the business perspective of like, for every month that you're updating and eliminating tech debt or whatever, that's a month you're not producing new functionality or new features.
And that's usually the problem, because when you talk to an engineer, they will tell you, yes, but I need to work on, I don't know, this nice new feature for the TV UI, let's say. And this is gonna generate this amount of money versus I can go and do your refactor. What am I getting out of it? So we need to really find the balance between asking them to do things that don't provide value, that provide value. This is why automation is key for us, because we have failed in the past on two things. One is surfacing the real value of doing something. Like, can this be translated into time savings, money savings? And second one, we cannot push multiple migrations at the same time. Like, you will see security asking you to do new ways. You will see people asking you to go to a new framework, then somebody else telling you to go to a different database. Like, there is no way you can keep going with that and continue delivering business features. So I think we are more like, not forced but incentivized platform teams to try to take away work from engineers. I don't know what's gonna happen, honestly. It seems like very optimistic at this point. The reality is that even delivering change with confidence is hard, because you don't know what people do with their software. Instance, like, do they write tests? How do they write them? Is running their tests enough to say, oh yeah, you are fine? We have seen people that do canaries. We cannot just run canary every single time in production and take down Netflix. So there are definitely a lot of, I think at this point it's not even about software, it's really about culture. And we are trying to change the culture when it comes to verification of software and how we deliver the change. So that's why it's hard. I don't know if that makes sense. I guess a year from now, I might be having a talk on how we failed or how we succeeded. I don't know. Who knows?
How we learn.
Yeah. I mean, it's okay to fail, but we need to try it. And we truly believe that we can deliver these kind of things, but it might not work out. It might be that people don't like it. So it's hard, like the whole internal, like, I wouldn't say a skill set, but the way engineers approach their development life cycle is way different. You can see people that want to be hands-on, like for example, the whole like managed delivery team. There are people that really appreciate that, like, I'm just a click away from deploying something. But there are other engineers that they would like to get their hands dirty. They would like to really understand those things. And yeah, we allow them to do, but it's not the pay path. We don't want you to do it. So as an engineer in product, I will say it could be difficult if we start doing more things for you, because especially if you are in early stages of your career, you really want to get your hands dirty and try to learn more things. So I think we need to find balance on what we allow people to do or what we recommend people to do, so they can also get, experience. The last thing we want to do is have folks that only know how to write a Spring Boot controller. Like, we want them to understand what operational of an application means. We are going to provide the tools, but also we need you to understand how this works and why it works this way. But it's easy to fall into the trap of, we're just going to take care of everything for you and create a lot of abstractions and make it easy. And then there is no value for anyone. Not for the engineer, not for us, and not for the company for sure, because there is no talent development. That's That's my personal opinion. Don't quote me on that. Cool. Well, thank you very much. Hopefully this was kind of helpful in some ways. I guess the message was along the lines of we all suffer from this. There are things that we can do. I'm always happy to chat about anything on this, or even like the Gradle specifics, the realities that I wanted to take away. This talk was in the past more about like, do the resolution rules live demo, things like that. But I have found that people don't use Gradle, so it's like useless for them. And I don't want people to go to Gradle just because they want to do something like this. So yeah, if you have any feedback, any thoughts on how this could be better, or if they shouldn't be a thing, I'm happy to take that. Yeah. Cool. Thank you.